All right, so if you do notice that there was something missing, and you know that it was done, but it's not in the grade book, unless you just submitted it this weekend. If it was something from a while ago and you're like, Strub, you didn't grade this quiz yet, or this missing assignment, shoot me a quick email, and then I kind of have an electronic record of it, and I'll go back and I'll get that done in the next couple days here. So hopefully you kind of have a good idea of where you're at. Let's show you where we're at with the rest of this school year. It is going to fly by. It kind of already has. So this is just kind of our rough week. So last week we learned radicals, inverses, and compositions. We did a quiz on radicals. And remember, you can take each quiz up to 3 times, and it always takes the highest score. So if you didn't do well on a quiz, you could go back, and if you have more attempts, you can go do that to boost your grade. This week, we're going to actually do a Desmos activity, which is why we need our computer out. And we're going to look at graphing square roots and cube roots. And then notice our homework. Our homework is to work on missing work, or you could actually start the chapter review assignment that's going to be assigned on Wednesday. And we're going to review for we'll call it a test. Oops, that's instead. Because I created it. We're going to review for the test on Wednesday. And notice the test isn't as much as the other tests, because we didn't spend much time on this unit. It's like a mini unit. It's still worth more than a quiz, but it's a 30-point test on radicals. So basically over the last week and a half. And then we've got the next week, we're going to do something on rational functions, and it's going to be another mini unit about 2 weeks long. And we're going to kind of take that same process, doing operations, add, subtract, multiply, divide. Then we look at solving, and then we're going to look at graphing again using a Desmos activity. So the work we do today with Desmos is going to continue on with, in a couple weeks, doing Desmos again. And the reason why I say that is look at kind of our last week of full school it's a Desmos project. So what we have here is we're going to have kind of some big work days where you guys get to design your own project based off of the equations and functions we've studied this year. I will go into great detail about that and show you some examples from years past. But that's kind of a nice relaxing week that if you are really productive in class, you're not going to have a lot of work outside of this. And then we're not going to have a final. Really, we're going to do a little activity. Actually, I won't see you guys on Monday. So our last day is kind of a touch base. Let's do a survey. See how the year went. Are you missing anything? This is your last opportunity to get things done. And then we're done. So we really only have the test on Friday, another small test on 2 Fridays, and then a project. And the project will be about 30 points, roughly the same as one of these small tests. So we still have a lot to do, but it's going to go by quick. Let's just count the weeks. 1, 2, 3, 4 weeks of actual production, and then a last week of wrap-up. So we don't have a lot left. And the same is true for your other classes. Make sure you're just aware in general of what do you need to do to get the grade that you want. And hopefully we're not in the point where anybody's at a point where they're struggling to pass. But if you are, you want to make any last options here. Start working now at getting your grade up. Okay, so before we jump into Desmos, we're going to do a quick review. Actually, I didn't have it on here. Shoot. I was going to pull up, I noticed from the quiz and from the Delta map that we struggled in one small area. I didn't save my edit, so I'm going to pull up one small thing here, and we're just going to do one quick problem. We'll treat it as a warm-up. And let's do, this one's kind of fun. Maybe it's not a quick problem. But I noticed we struggled a little bit on this idea of composition of functions when we had equations. So I'd like you guys to try this as a warm-up. express your answer as a polynomial in standard form. Your goal is to find g of f of x. I'll give you about 2 minutes to work on this. All right, let's take a look at this one here. So remember the composition of functions. There's two ways to write what they have here. They could write g of f of x, or they could use that notation g of f of x. That little circle O stands for of in math. So you should be aware of either of those two. I'm definitely going to have to recalibrate this. What are we going to do? We have to take g of f of x. Well, what is f of x? It's x plus 7. And the way I like to think of it is whatever f is now going into the function g as my new input. Now, the one thing that's really interesting here, see how g has two values where it needs to have an input? So I'm going to put x plus 7 into both of those x's. So the way I would write this then is, I know I'm not going to have enough room here, is I'm going to have 2 times x squared minus 5 times x minus 12. But notice I didn't write x because that's the input. Well, the new input is x plus 7. So I'm going to put x plus 7 into each one of those spots, and then I have to simplify. Now that's the new part right there. It's just putting the composition of function, or f, into g. Now I got to do whatever algebra I need to do. I'm going to do a little bit of side work to do this part right here. X plus 7 squared. Now you might be able to do it in your head, or remember what it means to be squared. You have to multiply it by itself. And that's usually an error I see kids do, is they don't FOIL. So you guys can distribute or use the area model. And when you're all done with that, you should get x squared plus 14x plus 49. So that's going to replace the x plus 7 squared. And then I still have to deal with this negative. Now notice, minus 5. I'm distributing the negative and the 5 to each one of those. So that's another error that's very common. The students often miss the negative going to the 7. So it's a negative 35. And then I have to deal with this 2 out in front. We're going to multiply the 2 together. So I end up with 2x squared plus 28x plus 98. And then everything else drops out. You can simplify differently if you combine like terms here. But now the last step is just combine your like terms. So I only have one 2x. But then I've got 28x and a minus 5x. So it'll be a positive 23x. And then I've got a 98 minus 12, which is 86. And that is 35. What's that? 35. Oh, the 35, hey. So then I'll subtract 35 from that. That's 51. Yeah. Thank you. Good catch. Wouldn't be a math problem if I didn't make a small mistake, right? So, I hope that you guys are a little more comfortable on this. When I checked the Delta Math assignment, there were more mistakes on the g of f of x or when we're plugging in the function. So that's something you might want to go back and look at. All right, any questions on this whole process? Okay, good. So what are we doing today? Good thing is you don't have really any notes to take, except for right at the end of our Desmos. So you don't need to write any of this part down. I'm just going to kind of show you what we're doing today. Our goal today is to look at square root and cube root functions as graphs. We've looked at them as equations and how to solve them, but we haven't really looked at their graphs. So today we'll be using Desmos to explore the graphs of square and cube root functions. You may remember these graphs from Algebra 1. So I'm just going to show this to you quick, but you're going to actually explore why and how it all works. So when we say square root, its function has a domain and range. We're not going to do a lot with domain and range. It's something we're going to skip. You'll hit more domain and range next year. But you can see, how do I get 0? Well, if I plug 0 in, the square root of 0 is 0. What if I plug in x equals 1? The square root of 1 is 1. And what if I go over to 4? The square root of 4 is 2. So you can see this is going to grow, not super quickly, but that's the graph of the square root function. Well, it looks somewhat similar to a cube root function, except for a cube root, we can actually do negative numbers as well. You can take the cube root of a negative and get a value. It just has a slightly different shape, and that's what you'll be exploring today. So right now, you're probably not super confident in this. You might not remember it from Algebra 1. We're going to do a Desmos activity, and actually I want to show you one thing quick before you get there. Your slide is going to look slightly different than mine, but I just want to show you where you can find things on Desmos. So, like, let's say I want to graph an equation. I'm going to start with y equals, we just go to the sidebar, and then, of course, you guys can't see it. See this little symbol right there? Maybe I'll move this down further. There we go. This little symbol right here is a keyboard. If you click on that, it pops up with a bunch of different options for you. So watch this. I don't see a square, oh, there's a square root function. So if I wanted to type in a square root function, I would do the square root of x, and then maybe I want to put something underneath it. Maybe there's a -2 under there. But if I want to go outside of the square root, if I want to put a number after it, I have to press the arrow over so I get out of the square root. So let's say I put a +5. You can see that this graph, and I can change it, scroll in and out so you can see more of the graph. You can even click on it to follow points. Okay, but that's just a quick way, and if you screw up, you can easily hit X and get rid of it. Well, let's say I wanted to do the cube root. This is where you really got to pay attention. There isn't a cube root function right on here. So if I do y equals, where's the cube root function? If you hit this functions button, it gives you another menu. And then you got to just kind of check and see. Most likely it's under miscellaneous. And right here. Does everybody see that nth root? So watch what happens. I don't want an nth root. I want the cube root. When I hit that, it's going to tell me to type in the index number. And a cube root would be a 3. And then you can type in x. And I'll show you this. We will have these in there already, but you're going to see values like h and k. See, as I typed those, right underneath it popped up and it says, do you want a slider for these? If you were typing your own, and it says, do you want a slider? Anytime you type a variable other than x or y, it's going to ask you if you want a slider. And all that is, if you click yes or all, it gives you an option. So then you can just slide this. And notice how if the number changes for h here, you can see what it's doing to the graph. So we already have sliders put into place for you, which means you get to explore just by going like this. And what you should do is look at the graph, but also look at, well, what would that look like in my equation? So like, notice, if I have x minus h, and then it says h is -4. If I plug a -4 in right here, it's going to be minus a negative, which would actually read as a positive. Okay, so you got to be careful with that. And the one reason why we know this is, remember, let's do this. We didn't do a lot with this either, but what if instead of a square root, what if I used a square? So notice I typed those in, A, H, and K, and they say, do you want sliders? Sure. Well, look at what we have here. We have a parabola. That's really weird. Oh, because it's already at 1. Oh, they're not at 0. But if H was 0, you can also type in a 0 there if you want it. So you can type numbers in, or look at what I have here. I have a parabola, and we studied those in chapter 4. Now, remember how we talked about what the A value did? When A was positive, it made it get a little narrower. When A was less than 1, see how it's getting wider and wider? And then when A is negative, it flips it over. That's the reflection, right? So we could have explored these graphs a little bit in Desmos, but then we didn't really do a lot with H and K, and that's actually your goal today, is what do you think H and K are going to do to different functions? And here's the hint. It doesn't matter what the function is. It could be a square root, a cube root, or it could be a squared like a parabola that we have here. The H, the K do the exact same thing to the functions, and you might already have an idea right now. But what I want you to do is compare it to how it would be written in the equation. All right, so your goal is to explore today using Desmos. And just remember, this little keyboard here is how you can find things, and then there's a function miscellaneous for the nth root. Another way to do it is if you program it and type in sqrt, so you see how I SQR, and then as soon as I hit T, it turns into a square root. So if I did, and this is where I'm not great with the type, I don't think it's N. Can't see. Okay, yeah, that didn't work. Maybe it was just N. There we go. So we do, no, that's not it. It's in our Desmos slide, a shorthand type to get the nth root. That's new to me. I haven't done that a lot, so I actually forgot what it was. Anyways, that's your job right now, is to explore. And this is my classroom code. So if you go to student.desmos.com, type in the classroom code. You may already be a part of this, so it might actually log you in already. And then you should see up top an assignment that says graphing square and cube root functions, and there's 21 slides. So you're going to go through those slides, and some of them are just explore and pay attention to the sliders. Others are type in your response. What do you notice? What do you see? And then some might be matching a graph, some might be matching an equation. And there's a tiny, tiny error on slide 15 that I could not fix yet. So I want to show you that once you guys are logged in. I'll show you what this looks like too if you're not there yet. Let me show you slide 15 just in case people are already starting to move on. So slide 15 is right here, and it says graph a cube root function that has shifted, and this will make more sense when you get there, but it's shifted 3 units to the left, 1 unit down, and has a vertical stretch of 2, and is reflected over the x-axis. Type your function in. So all of that's fine. here's the error that I actually could not fix yet. If I can fix it, I think by the time you guys started, I won't be able to fix it. This blue dotted line is the parent function. So your answer on slide 15 is not going to match this blue line. It's going to be a different shape. It's going to be stretched, but this is how you start. So if I typed in the cube root, now, so notice it says cube root. That's how I know to start with. Why can't I get to the miscellaneous? All right, well that one's not working, but somewhere over here it gave me the shortcut. Let's see. I don't know if it's because I'm in a different view that I can't see that miscellaneous. Oh, here we go. If you type in nth root, so that's what I needed for 15. So anyways, if I type in nth root, you can see it went to that nth root, so I would type in a 3. And if I just put x, see how that started where I need to go? Now I would plug a number maybe in front, maybe like a 3. I plug a number inside, maybe a +2. And then, oops, I need grouping symbols here. And again, I'm not following the directions, but if I do that, you can see that my graph changed its shape. So number 15, just kind of ignore that last little piece. Your answer isn't going to match the blue dotted line. It's how you start, and then you have to meet the items there. So you should be, and it looks like people are on this slide, read everything very carefully, and your job then is to progress through. I'm on Zoom, I'm in the classroom. Raise your hand or throw it in the chat when you have a question. And if it's a very common question, I will stop the class and go over it. And I can do that by just hitting pause. So keep in mind, I can see all your pacing and all your work. So I'm going to follow your progression as we move through here. All right. Let me show this code again just one more time. Oh. So if you haven't had a chance to log in yet, go to student.desmos.com, and then when you get to that search bar in Google, type in this code, and then go ahead and start working. The activity is called graphing square roots and cube roots. So, and let me know if any questions come up.